I'd like to remind everyone that this session will be recorded and available on YouTube afterwards. My organization, IBHS, is an independent 501c3 nonprofit scientific research and communications institute enabled by the investment of the property insurance and reinsurance industry. At our one-of-a-kind research center, we recreate wind, hail, rain, and wildfire to study the resilience of the built environment to severe weather. At full scale, we test residential and commercial structures so that scientists can see what fails first and understand what we can do to protect the investment of property owners. We always strive to translate our research into real-world solutions, helping to create resilient and thriving communities. So today, we have a terrific panel for you that's going to focus on building communities that can withstand coastal hazards. I'd like to remind you to put questions into the question box, the chat box, as we've reserved time on the back end of this panel for discussion and answering audience questions. Before I introduce our esteemed panelists, I'd like to do a little bit of table setting for our conversation today. When our children's grandchildren are in school, they're probably going to be taught that 2020 and 2021 were years of compounding crises, a time of COVID and of climate change. As tracked by NOAA, 2020 set a record of 22 different billion-dollar weather and climate disasters in the United States. And in 2021, there were 20 of them. Due to rising ocean temperatures, the southeastern US and Caribbean region likely will contend with hurricanes of increased maximum intensities for years to come. In this context, resilient communities that have adapted to climate change are more important than ever. As a building science institute, IBHS focuses on the ways that weather behaves, what makes homes and businesses vulnerable, and how our buildings can become more resilient. To break the cycle of destruction, it is essential to address all aspects of the building performance chain: where you build, how you design and construct, and how well you maintain and repair. When it comes to communities, we need a similarly holistic approach, looking to all the different parts of a community that serve and support people, including housing, water, energy, roads, pipelines. Failure to account for the resilience of any of these community building blocks can result in cascading damage when natural disasters occur, like we saw in the winter storms of early 2021 in the United States. We need to pair this holistic vision with a multi-hazard approach to natural disaster resilience, particularly in coastal regions. Hurricane-prone regions face numerous perils, including storm surge, flooding, high winds. For instance, concentrating resources on flood resilience may hold back rising waters, but it will not shield families from the dangers of high winds. And lastly, we need finance streams from both public and private sector sources that can help communities, businesses, and families pay for the mitigation actions necessary to strengthen climate resilience. We know that the effects of climate change and extreme weather events are not felt equally, and that many who live in areas with elevated climate risks have fewer economic means and less ability to both withstand and recover from severe weather. Equity demands that we identify ways to deploy capital into the regions and communities that need it the most. Collectively, this is no small task, but it is a necessary one. Our panelists today are going to help light the path forward. First, we'll hear from Lori Shellman from Enterprise Community Partners, who will speak about Enterprise's work on behalf of resilient communities in Puerto Rico and beyond, as well as Enterprise's Keep Safe Guide developed in the aftermath of Hurricane Maria. Andres Terrizzo from Watershed Consulting Associates will teach us about watershed restoration and resilience, focusing particularly on the 2020 Watershed Management Plan update for the Coral Bay watershed in the U.S. Virgin Islands. John Johnson of McWane Ductile will speak to natural disaster threats to our buried pipelines that maintain safe drinking water, fire protection, and resilient sewer systems, and the way that proven designs and materials can increase the resilience of these vital infrastructures. Shana Jones from the Carl Vinson Institute of Government at the University of Georgia, and congratulations on your national championship, by the way, will provide a high-level overview of the legal framework of duties, immunities, and takings laws surrounding decisions related to the protection, elevation, realignment, and even abandonment of coastal roads. And finally, we're going to hear from Julie Chailloux-Woodard, the president and CEO of Smart Home America, who's going to speak about why housing is an essential component of infrastructure, linking the resilience of housing to community and economic resilience. In her recent book, The Fight for Climate After COVID-19, Alice Hill, who was recently nominated to be the next Deputy Administrator for Resilience at FEMA, notes, and I quote, "The World Bank estimates that across the globe, multi-billion-dollar infrastructure projects and master plans for tens of billions of dollars of investment frequently fail to consider the implications of future climate change." She reminds us that until planning for climate risk becomes routine, communities will continue to be vulnerable to greater damage. As we listen to today's panel, I urge you to keep Ms. Hill's words in mind. And with that, I'd like to call upon our first panelist, Lori Shulman from the Enterprise Community Partners. Lori, can you turn on your video, please?
Thank you so much, Michael Newman. That was a great, thank you so much, Michael. That was a terrific introduction to this important topic, and I'm really happy to be with everyone today. Just if you guys can just let me know if you can hear me okay. Okay, great. So I'd like to get started. If I could go to the next slide. Enterprise Community Partners, next slide, please, is a national nonprofit. We've been working in and around the nation and including work in Puerto Rico and the VI for close to 40 years. We are a nonprofit organization that has a sole mission to make sure that there's affordable housing across the nation that is going to meet the needs and the demands of communities across the country. We know that there is a significant shortage of affordable housing all over the nation, and that all of the affordable housing we do have in place is safe and protected from natural hazards. And we know that more and more there are an increasing number of affordable housing units that are in harm's way. So the goal for us is to ensure, and in my program, is to really ensure that this housing is protected and safe and resilient for climate hazards. Next slide, please. The way that we do this right now is to focus on three pillars, really, that inform the work for us. One is increasing housing supply, which of course increases the ability for communities to be able to respond from hazards. Advancing racial equity. We know that the developers and the entities that are building our affordable housing need to reflect the communities that the housing is being built for. So increasing the diversity of developers and making sure that they have the tools they need to do their work is critical. And then building resiliency and upward mobility. This is where the climate work specifically comes in. Next slide. The issue we are facing, next slide, please, thank you, is that there is a new normal that we need to come to terms with. We are in a place as a nation where a lot of our work has now moved inside because of COVID. Home has taken a very different role that it has traditionally. It is not only a shelter, but it's a place of work. It's also a place where medical needs are considered when we think about the epidemic in the last 2 years. That home has become a place, a sanctuary, if you will, for ensuring health of households. And so the new normal is also confronting us with the reality that the climate is changing, that sea levels are rising, that extreme temperature is upon us. And this asks us to confront and design and develop housing in a different way than we ever have before. If we turn to communities such as Puerto Rico or the VI, these extreme events that occur are occurring with rapidity, and they're occurring with extreme consequence. So our challenge in front of us is to make sure that our housing can hold up. Next slide, please. And the key here is to make sure that we really respond to what Michael had mentioned before, which is these events are costing our country more and more. We have an extreme scenario where, you know, a lot of communities have moved to the denser urban environments. And so that means that when an event hits a community, if an event hits San Juan or comes to St. Thomas, there are more people living there. And so the cost and the implication grows larger and more expensive. We also know, next slide, please, that a lot of communities have been facing a legacy that informs how recovery will play out. So policies such as redlining, which was the active disinvestment of funding into communities, specifically communities of color, as well as the planning practices that were put into place in the early part of the century, putting highways in place of communities, relocating communities out of safe zones to floodplains. All of these events and histories really inform what our shape of the communities are today. And when you add a mix of extreme storms or extreme weather, we have a recipe for disaster, quite literally. Next slide. And it's worth mentioning that the amount of affordable housing shortage cannot be understated. This is a specific concern in Puerto Rico in the VI, where housing is just unaffordable. For most community members that work and make a wage in these communities, there's not enough resources to purchase or support a house. And so the marker of unaffordability is if you pay 30% or more for your housing expenses per month. And certainly this is a problem for a lot of communities. And so when we have the housing units that are undermined by extreme weather, they are not replaced easily. Next slide, please. And we see this particularly in the VI over and over again, where residents cannot afford to live, and the repeated losses that are occurring with rapidity for communities is creating an incredible burden. Many of these repeated losses translate into lowered cost of assessed value of the home, and for many communities, assessed value is part of the generational wealth. So when we lose the value of the home, we're losing a legacy that can be passed on to generations. It's also worth noting that because of the rising costs of insurance and the incidence of valuation changing within homes, we're also seeing a lot of assets getting stranded, quite literally. Next slide. So we're working deeply in many communities across Puerto Rico and the VI to try to understand what has happened in previous years to inform where we are today, and then to look forward to see what we're actually building our housing to, and what conditions we should be considering as we go forward. Next slide, please. And we see that, again, these events are occurring with rapidity. So when we work with partners and we work on the ground, we always bring in partners to make sure that we're collaborative and facilitative entities in a community. And so I'm going to introduce you all to a book that we created in Puerto Rico called Keep Safe. Next slide, please. Keep Safe was a build upon on a book that we created years ago after New York City's big event, Superstorm Sandy, occurred, where we built a book called Strategies for Multifamily Housing. This was built with communities in New York City, with affordable housing owners. Next slide. And this book looks at how do we deal with certain issues around flooding, how do we treat multifamily housing buildings. This is a particular housing stock that has a particular set of needs. So we worked with those owners and operators in those buildings to figure out what specific mitigation strategies would be necessary to support that building through a flood event. Next slide, please. And so when Hurricane Maria happened, I went down to Puerto Rico with our team to work with our partners to try to figure out how we could be helpful in supporting recovery. It's worth mentioning that we were no stranger to Puerto Rico. Enterprise had been in Puerto Rico working to build housing and facilitate affordable housing for close to 30 years. So we have strong, long-standing partners on the island, and we immediately got into gear to figure out what we could do to support recovery. Next slide. And the next slide, please. And the damage that was occurred in Puerto Rico after Maria was enormous. 90,000 homes were damaged or destroyed by the 155-mile-per-hour winds. And this was an event like none other. The world watched how so many communities were stranded by the electrical grid or left really trying to feel through how to get tools and resources and water. It was a terrible, terrible scenario for the many communities that are in Puerto Rico. And next slide, please. And one of the biggest concerns we faced was the electrical grid just was not up to the conditions that were waged on it. I mean, we had distribution lines scattered all across the island, and still a lot of energy is still not back. Almost 80% of the island's crop value was wiped out. So the losses were huge. And what happened was a lot of housing units were just uninhabitable. Next slide. So we got into gear and brought together partners to create what I'm proud of today, which is a book that details how to build resilient housing in island communities, specifically in Puerto Rico. And our partners in the VI have been a key partner in promoting this as well. Next slide. The question we asked ourselves was, what do we do? How will housing get rebuilt in Puerto Rico with all the funding coming in? How will it be able to protect and withstand the conditions that we're facing now and going forward? So next slide. We pulled together partners from the University of Puerto Rico, the Builders Association, the two sponsors of this guide, and we came together with leaders such as Lucila Marvel and others to try to define and identify what we mean by resilient housing. And over a period of intensive work together with over 150 partners across Puerto Rico, we came up with Keep Safe. Next slide. Manténgase seguro. Next slide, please. And this is a book that essentially details how you site, build, design, operate your facility. We look at a variety of aspects of what it means to have a resilient home in an island community. Next slide, please. And essentially, what we first ask is, what are your risks? Is it water, hydraulic? Is it air? Is it land? In Puerto Rico, we have all risks, right? So we're dealing with all of the risks that confront us. And this is a critical piece because it is a very unique scenario. Many communities don't have all risks, and Puerto Rico has to understand all of these risks now and going forward. Next slide, please. And we take those risks and we interpose them with housing and the site that you're building on. The book is intended for the layperson, a person who may not be a trained architect or designer. This is a visually compelling book that helps anyone who's touching housing understand where they should be focusing. Next slide. So the main sections of the book are essentially starting from the sequence of how you build. Introduction, moving through the safer site, what's on your site, what are the conditions, moving into building protection, what are the bones of your building, then moving into passive habitability. How do you develop and build the house with an understanding of the natural conditions around you? Then we move into energy generation, backup. Chapter 5 takes us through water management and water catchment. Then we move into household preparedness, community engagement, and then we stop with how do you put it together and build it. And I'm just gonna, Michael, I'm just gonna wrap up. If we could just move through the next couple slides. This is a big book. There's a lot there. So we go through soil orders. We go through where the site is. We move through what does the grid mean? How does it intersect with your housing? Next slide. We're learning from the past and adapting for the future. And that's a lesson I would communicate to all of us today when we think about housing in the Caribbean, because there's a lot we can learn from the lessons of the past. Next slide. We move into all of these different systems. And if you could just go down to 32, I'm gonna wrap up. looking at solar orientation, looking at all of these different features of the site. Next slide. And then if you go to 32, we're also looking at community scale work. So how do we build community centers that are going to be resilient and able to help support communities? And I am going to just ask whoever's leading this, if you could go to the final, perfect. Communities together, how do you build a community infrastructure and community resiliency center? And then just to conclude, this book is available. We train up a lot in Puerto Rico and the VI on it. We've also taken it to Florida, so we've got a Keep Safe Miami effort, and we're using this book to inform a lot of our work around the country. And so I would just say I'm really excited to be part of this conversation today. Contact me if you'd like a copy of the book or if you'd like to have any more information about this really important piece of guidance. Thank you.
Lori, thank you so much. Really inspiring work. Thank you. And next, we're going to turn to Andres Terrizzo from Watershed Consulting.
Great. Hi, everybody. So my name is Andres Terrizzo with Watershed Consulting. I'm just going to launch right in here. I have a bunch of information to share in a shorter period of time. The project that I'm going to discuss was prepared on behalf of the Coral Bay Community Council, a small nonprofit in St. John, U.S. Virgin Islands. This was funded by the Department of Interior, a Watershed, a Water Smart grant. So St. John, for those who don't know, is located in the U.S. Virgin Islands. The Coral Bay is actually on the east end of St. John, shown there, highlighted in orange. Next. Next slide. Doesn't seem to be advancing on my end. I apologize. Is anybody able to reload this presentation and advance it? Doesn't seem like it's the PowerPoint is advancing.
I'm on that, Andre. Just hold on a second, Andres.
What I'm going to be discussing here is just to give you a quick overview of some of the existing characterization of the watershed.
Are you able to see my screen? Okay, great. Thank you. Just tell me when to advance the slides. Oh, we Meredith, who was advancing previously, lost connection. Thank you. Please go on.
All right. Oh, gotcha. Okay. So back up just one slide if you could. And there we go, perfect. All right, so talking about the existing characterization, we're on the east end of St. John, the Coral Bay watershed. Next slide. So the main watersheds in Coral Bay, there's within where the Coral Bay Community Council manages is Great Lampshire, Coral Bay, and then Mennebec Bay. So the watershed that we were focused on in this watershed plan update was the Coral Bay, which is the main watershed shown in orange in the middle. And I'm not sure I actually mentioned that. So the work that I'm doing, I'm just giving kind of a technical snapshot of some of the analysis that went into the watershed management plan. But essentially, Coral Bay watershed management plan was updated. It was complete at the end of last year, so this is good. This was a 5-year update. So now there is a new version that's available and is going to kind of carry forward the next 5 years. So that's where this information has come out of. Next slide. So within the main Coral Bay watershed, there's 19 sub-watershed areas. Those are shown here in red, around the different parts of the bay. Next slide. Coral Bay is a very steep area. This is a map here just showing the excessively steep slopes surrounding the watershed. Reds up on the mountaintops, and then yellows. Those are all very excessively steep. The only flat land is really, you can see in green in the kind of the middle of Coral Harbor, and then some of the other areas around the fringe of the harbor, but generally very steep conditions. Next slide. Also very poor soil conditions, poor for retaining stormwater and infiltrating stormwater. This is a soils map showing that the D soils and the C soils, which are the soils which are less conducive to infiltration, predominate in the watershed. So this is another reason for kind of high runoff conditions in addition to the steep slopes. Next slide, please. So when we started this work, there were also a number of infrastructure points, asset points mapped, and we had done some refinement of those points as we went along. But just to give you an idea, all those points are either things like culverts, swales, water bars, that type of infrastructure. So, Coral Bay, it's predominantly a residential area. It's the development is kind of diffuse. There is kind of a more of an urbanized center, but there's also then a lot of diffuse development up the hills, which really involves a lot of roads and driveways, and then residential units that kind of surround the main town area. Next. So what we had done as part of our plan was we had used a water quality modeling tool called the Watershed Treatment Model. So this was it's a spreadsheet tool developed by the Center for Watershed Protection. And the goal that we had was to investigate the location and severity of land-based sources of pollution. Because there are quite a few issues with land-based sources of pollution. We needed a tool to be able to assess nitrogen, phosphorus, suspended sediments, and fecal coliform based on all these potential sources here. Land use, soil type, sewage use and disposal, gut erosion, and marina characteristics. Next slide, please. So really we were focused around the impact of Hurricane Irma and Maria in 2017. That was really the defining moment in the past 5 years. So, and you can just advance through a few of these. So the first, we basically modeled 4 conditions. First condition was in 2015 before the hurricanes. The next condition was 2017, directly after the hurricanes. And you can see this image that's shown right here. This was clearly like right after the hurricane. So we looked at the land use conditions right after the hurricane. And then what we did was we looked at the current conditions. And the current conditions assumed 70% of those homes or businesses that were destroyed were recovered. And that was based on data from the Coral Bay Community Council. So obviously when there's damage that occurs to these places, that means that there's disturbed land. Those areas are more prone to erosion and sedimentation. And then as things recovered, those homes were restored, rebuilt, and the land around them was then stabilized. So in the current condition, the 2020 condition, we assume that 70% of the areas that were destroyed were recovered. And then the final condition was this full hurricane recovery condition, which is the future condition. Next slide, please. So the results of that, looking at these watershed treatment model pollutant loading results, was that if you can just turn your eye to the bars there on the right side, there's one for each pollutant, and you can see that across the x-axis are the different conditions, so 2015, 17, 2020, and future. The loading of these different pollutants to the bay increased pretty dramatically in 2017 from 2015. And after 2017, when things started to recovery, in 2020, when we had 70% recovery, you can see that those loading values started to go back down. In the future condition, when we assume a full recovery, we're almost back to where we started. We're actually slightly higher than where we're starting in 2015, and that's just due to increase in new development in the watershed. So that trend of kind of peaking right after the hurricanes, you can see was constant with all the different pollutants that we modeled. Next slide, please. So the other thing that we did was we looked at road paving as a best management practice in Coral Bay, and that might seem odd to some because typically paving roads is not considered a stormwater best management practice. However, the conditions in Coral Bay really necessitate stabilizing a lot of roads. You can see in this upper photo, the roads are incredibly steep and they really do act as a conduit for water. And given that the unpaved roads are really, in a lot of cases unstable and not really being developed with proper hardened material on the surface, you can get a lot of erosion right down the road, and the water really follows right down the road and carries a lot of the sedimentation down to the harbor. So we really looked at, well, what is that unpaved road network? What's the effect of that in terms of sedimentation to the harbor? And go ahead, next slide, please. So what we did was we took one of the sub-watersheds. This is Johnny Horn Trail sub-watershed. We did a test analysis to where we investigated what it would take to actually, if 25% of the unpaved roads were converted to paved, what would that do? And it showed that it would actually have a fairly significant impact on pollutant loading, not just TSS, but nitrogen and phosphorus as well. So we expanded that analysis to the rest of the watershed. Next slide. And so when we expanded it to the rest of the watershed, we learned that yes, paving to an extent is really important as a BMP and really does have a place in the watershed as a way to manage sediment and erosion to the harbor. Next slide. So, but we didn't really know where in the watersheds the road we should be recommending paving to occur. So what we did was we did a second analysis to look at the slopes in relation to where all the unpaved roads were located. Next slide. And what we had done was we came up with a measurement of there's 28 acres of unpaved roads in the watershed. We divided those all up into 100-foot segments, and we calculated the average slope, and then we categorized those by low, moderate, or high slopes. Next slide, please. So the other piece of modeling that we did was we actually modeled flow as well. So we modeled peak flow, and we modeled peak flow because we were interested to understand how peak flow also influenced water quality impact. Next slide. And so what we had done was we had used a tool called HydroCAD for that. We had modeled, the 1-year storm event, about 2.8 inches in 24 hours. We modeled that for the 19 sub-watersheds that I presented at the beginning of the presentation. Next slide. So the results here show, these are the bar graph on the right is for all of the sub-watersheds. You can see it really, unsurprisingly, the largest sub-watersheds have the highest flows. And you can just click through here, each one of the bullets as I speak. One of the interesting results, Johnny Horn Trail in the middle, that's a really small sub-watershed, but the peak was actually much higher than we anticipated. And we think it's due to the fact that the soil conditions in that area are especially heavy and not really conducive to infiltration. Therefore, higher peak discharges were generated for that sub-watershed, higher than expected. But really, just quickly in a nutshell, I think the modeling really showed that impervious cover alone will not be enough to reduce the peak flows. Really, it was focusing our recommendation on managing flow patterns at the neighborhood scale, and focusing on disconnecting impervious surfaces and restoring the natural flow patterns in the watershed. Next slide, please. You can just click through the final 2 points. I think I just have 2 more slides here. We basically took the results of the peak flow modeling and the water quality modeling using the WTM. We put those 2 together and we did a ranking analysis of all these subwatershed areas, giving each subwatershed a score based on the predicted water quality and peak flow, and use that to come up with a total score and then a total final rank in terms of the subwatershed areas that we're recommending really need the most attention first, where most of the pollutant loading is coming from. Next. And so here it is just in graphic format. You can see on the right, 1, 2, and 3 are right in the inner Coral Harbor. So those are our highest ranked subwatersheds. And the lowest 3 were ones that were draining to smaller, less central bays and really primarily undeveloped. I think my final slide here. Yeah, and you can just click through. Oh, back up just 1. Yeah, so the 3 highest there are in red, the arrow, that's Coral Harbor. And the really great thing was that those results really did check out with the visual results that people living in the watershed and also Coral Bay Community Council were observing in terms of where the sediment originates from during storms. It's really that inner harbor which is producing most of the sediment load. So it's a good check in terms of our methods. And I think the important thing is that this kind of lays out a nice quantifiable approach moving forward to take targeted action to reduce sediment and other pollutants to Coral Harbor. And I think it can be, broadly applied to other, similar watershed plans in the future. So I appreciate your time and thank you.
Yeah, thank you so much. Next, we're going to turn to John Johnson from McLean Ductile.
Good morning, everybody. Welcome from the left coast out here in California. I'm participating in this presentation today because I have a lot of experience on the seismic side. I serve on the ASCE, the American Society for Civil Engineers Seismic Task Committee. So even though I'm out here on the West Coast, these type of issues are very, very germane for your part of the world as well. Next slide, please. So one of the things that's going on in the U.S. that mid to larger communities are having to respond to is the American Water Infrastructure Act. This act requires utilities to assess their the resilience of their infrastructure from not only malevolent acts, but also natural hazards. So that's what we're going to be talking about today, is how to make water systems and wastewater systems more resilient in order not only to comply with the American Water Infrastructure Act, but also to greatly bolster your communities, even though this act might not apply to you directly. Next slide, please. So anyway, as we've discussed in many of the different presentations already, we are seeing a dramatic change in weather patterns around the world. This slide kind of documents the risk factors for the Southeast United States, and not only from hurricane, but also storm surge, which, as many of you communities know, especially in the lower lying areas, can be quite devastating. Next slide, please. Here's a little bit more of a detailed slide for the seismic activity. Those that are in very active, seismically active areas are well aware of this, but also in the surrounding areas, even though you might not be in a red bullseye, the areas that are close to that also can be very much impacted. And you can see in the slide on the left down at the bottom, Puerto Rico is an extremely seismically active area. So they have the impact of hurricanes as well as the seismic activity as well. Next slide, please. This is a schematic that helps us identify what are the zones in your communities that can be most impacted by seismic activities and also storm surge. And one of the things that's very important to note on this slide here is look at the right-hand side of that slide and look at water, the bottom right, water saturated sand and mud, and then poorly consolidated soils. Though that water saturated sand and mud has the highest impact from seismic activity, the most risk. And so that's very easy for us to zone in on those areas as having the most highest criticality and the highest risk. But also at the base of a mountain here, where we have a lot of steep bedrock, but it comes down to a valley area, there's another zone that's number 2 for risk, and that's in the poorly consolidated soils in those areas. Some would say they're, alluvial soils. They're often the areas where homes are built that have a moderate elevation, so they have beautiful views. Unfortunately, those areas are some of the most seismically risk areas because of the poorly consolidated soils in those areas. Next slide, please. So anyway, when we're looking at buried pipelines, this is a lifeline for most communities. The water and the ability to have it and have it not be contaminated are critical to the lifeline of the community. Even though they're buried below ground, it's almost like our arteries. They're bringing the water and life-sustaining product to our homes and to our businesses. But one of the most critical things to keep in mind, besides just having clean water available, is fire protection. In the 1906 earthquake that hit San Francisco, the earthquake was devastating, but what really did the most damage to the city was the resultant fires afterwards. Natural gas lines broke, and it caused more devastation to the city of San Francisco than the earthquake did in itself. So when we're looking for seismic resilience, back one, please. Sorry. We're looking to maintain that hydraulic capacity, the ability of those pipelines to not separate, not become crushed, by the external loads and pressures from seismic activities. We're looking to maintain that hydraulic flow. We're looking to minimize any kind of shearing damage or compression on the pipelines. And of course, we want to prevent cross-contamination. Wastewater systems that are often side by side or relatively close to water systems, if they fail, then we've got cross-contamination as well, or force main spills. Let's go on to the next slide, please. So this is kind of a slide that kind of illustrates what happens when external loads happen to pipelines. Most pipeline materials out there, especially plastic pipe materials, require a trench in order to support the pipe material itself. Most people aren't aware of this, that there are actually external loads, and that if that trench isn't there, those pipelines will fail. They'll either become crushed, or they won't have the support that they need, and they'll split and crack, or the bell and the spigot of the pipe will separate, and then you've lost your hydraulic capacity. On welded steel lines in this bottom slide here, the external loads will actually buckle and can potentially shear off the pipeline as well, because they're kind of rigid. They don't have the flexibility, they don't have joint deflection in order to handle the differential ground movement for seismic activities. Next slide, please. So anyway, here's an example of that from a welded steel line where it's actually buckled. And what's happened in this line is the pipeline didn't technically fail, but that buckling reduced the hydraulic capacity of that line, and the internal pressure going through that section of the pipeline really dramatically went up. So when that happens, it's a ticking time bomb that you probably don't have a lot of time before that pipeline is going to fail. So it's an area that needs to be repaired and repaired quickly. Next slide, please. So anyway, we've talked about water saturated soils, and here's an example of what happens due to the effect that's called liquefaction during a seismic event. As you can see from the slide, this was a picture taken from Christchurch, New Zealand. Imagine, if you will, that's a home or a business that requires that support from the soil in order to keep that building from failing. So when the soils liquefy, it's literally very much like quicksand. The soil loses its ability to support anything above it, and that basically sinks down into the soils in that area. Next slide, please. So anyway, when we're looking for seismic resilience and we're looking at the different pipe materials in particular, all the pipe materials are not made equally. The higher the tensile strength of the material, the more likely it's able to prevent from buckling, from being crushed, or shearing. So as you can see, some of the pipe materials, as you go down into the plastic pipe materials, become very, very susceptible to seismic activity, differential ground movement, either loss of the trench, so the pipe doesn't have the support, or it gets into a situation where you have bell and spigot where they separate. So if forces are applied via tension or compression, they will also fail. So joint deflection is a very key component in order to provide higher resilience. And the systems that are out there, according to the ISO 16134 international standard for seismic resilience, are ERDIP systems. So let's go next slide, please. Here's an example of some ductile pipe. We call it river crossing pipe. You don't even have to have it in a trench. You can lay it across a bay, an estuary, and basically it has joint deflection up to 15 degrees here. It is a very, very valuable option for communities that can't dig a trench or want to go across a lake or stream or river or an estuary. And the weight of the material basically settles it down into the settlement and provides that all the support that that pipe material needs. Next slide, please. So anyway, the key components of an ERDIP system are high axial strain, joint resistance, joint deflection. Next slide, please. Well, anyway, here's an aerial photograph from a recent earthquake in Southern California called the Ridgecrest Quake in 2019. That diagonal line that goes from the top right down to the bottom right is a welded steel 12-inch pipeline. Next slide, please. When that 7.2 quake hit that area not far away, this pipeline failed. It was the sole source of water to a community called Truna, California. And that dark outline that you see there is actually water because of the pipeline has failed. Next slide, please. So here's what happened at that joint. It was a welded steel pipeline, and the Achilles heel of welded steel is where the joints are welded together, where the pipe is connected. And you can see the shear forces of that differential ground movement literally caused that pipe to fail. And that pipeline was only 40 years old. Next slide, please. So in order to increase seismic resilience, the pipe materials that can provide almost a chain effect are going to be more resilient. The chain effect allows the pipeline to deflect, to bend, but not fail. Next slide, please. So here's what the pipeline looked like in the soil. And then next slide. And here's what it would have looked like if we would have had that ERDIP system. It would have deflected, and it would have stayed together, and that system would not have failed. Next slide, please. So anyway, also with block displacement and movement, pipelines need to be able to have axial range where they can expand in tension or be able to move together in compression. ERDIP systems do that. Next slide, please. So anyway, here are some guidelines that are under development with the ASCE Seismic Task Committee. These are not finalized yet, but what this does is it helps the community use some evaluation. We look at the criticalities of that infrastructure, of that pipeline that you're looking at. Now, these will probably be finalized at the Pipelines Conference coming up in June of this year, but this is the type of thing that is under discussion right now. So what we want to do is we want to be able to adjust and look at the criticality levels and recommend commensurate levels of protection depending upon how critical that pipeline is to your community. Next slide. So this is where the rubber meets the road. You notice the color codes there, the commensurate gray, blue, yellow to green. The higher you go up in seismic resilience, here are the guidelines that are being discussed in order to provide adequate seismic resilience for your pipelines. Next slide, please. So anyway, when we're looking at an example from the ISO 161.364 international standard for seismic resilience, there's one material in it that provides the level of protection. Internationally, it's ductile iron. So let's go ahead and go into the next slide. So here's what we're looking at. We're looking at a pipeline's ability to deflect and also not come apart. That's the restraint joint for an ERDIP system. It deflects, but it does not come apart. And what we want to do is we want to address the seismic activity in that specific area and not transfer that tension or compression outside of those boundaries, because you could shear off pressure relief valves, hydrants. You can actually transfer that strain up and down, cut off connections to homes. So that's what we want to do. We want to handle that strain and that compression locally, wherever that event is, and not transfer it up and down your pipeline systems. Next slide, please.
John, I'm sorry, I'm going to have to ask you to wrap things up, please.
Okay, let's go up. Let's just go a couple slides. Let's go ahead and hit this one so that they can see an example of how this system would work. So with most of the manufacturers out there that offer ERDIP systems, it's normally a two-component system that goes together. And so this is an example of that system going together. And then the black segments coming in are the actual pipe materials. So the pipe material goes, and then you put these types of systems in areas where you're going to have very high seismic activity. And this provides even a higher level of resilience because it allows the pipeline to compress or go into tension and not fail, but also deflect. So the black segments there are the pipe itself that work in conjunction with the coupling. This illustrates how if there's compression on the pipeline, and this illustrates what would happen if there were tension on the pipeline, and then the joint deflection. And Michael, as soon as this video is over, we can wrap it up. This really, tells a great story here, what we're trying to do.
Great. Thank you so much, John.
Almost to the end here.
Pipelines are not something I have spent a lot of my time thinking about, so very much appreciate you demonstrating how this can work in a resilient fashion. Thank you so much. Next one.
It's almost here. Here's, oh, you cut it off right at the best part. It was going to illustrate what happens. Oh boy. Oh, if you can fast forward to where it goes into the illustration of the city a little bit further. It was almost over. There we go, perfect. This illustrates how that fire hydrant on the left is actually protected and not sheared off. So we don't have a failure and we could still provide fire protection. So notice how the pipeline deflects and it actually expands, and that strain isn't transferred over to that fire hydrant or connection to a home. So thank you so much, everyone. I appreciate that. At least we were able to get that in and illustrate how they work. Thank you.
Thank you so much, John. And moving from below the ground to above the ground, Shana Jones.
Hey y'all, that was really cool. And I can actually be quick, I think, if that would be useful to the group. So next slide, I am going to be talking about the law side and roads and resilience, and have some really great presentations related to physical things are happening, and we overlay all these physical things with words we make up, right? We manage them with law and we manage them with policy, and it really affects what happens in the built environment. So next slide, I will go fast, I promise. Just quickly, we are moving in a time where we live not just with big hurricanes and events like that, but persistent stress. And these stresses seem less immediate, but they are really what I think our local governments are dealing with on an ongoing basis, cumulatively. Next slide. So the road networks, it may be a sunny day, it may be a high tide, and this is what we're seeing all over. And people call their city council and they call their county commissioners and they complain about this, understandably. Over the past, I guess, 10 or so years, working with lots of colleagues, this is just a timeline of how we see sea level rise impacting the built environment. If you click the next slide, or click one more time, there'll be a little circle. I'm talking about roads because it seems like stormwater drainage is where a lot of the problems are, for sure, begin. But then roads are where people complain, and roads are what people see. And they're kind of the canary in the coal mine of sea level rise. And so we've been thinking a lot about the legal environment governing how we manage roads. Next slide. And if you click again, I do have some additional, oh, if you could go back, I'm so sorry. I don't know why that whole thing didn't come up. But what this slide should say is there's some big picture things to take away, is that these issues are challenging local governments. Governments have a duty to maintain roads, and so they can't just build something and leave it alone. They have to take care of it, and they have to keep both the public welfare in mind, the entire community, as well as individual property owners. So if they don't do a good job maintaining these roads, they can be liable for violating their duty. They could abandon these roads, but then that could make them liable to individual property owners for a takings claim. And I'll talk about this again. Next slide. And just this may seem an obvious point, but our road networks, we live in a government, a society that has federal, state, county, city, and private roads. And what we have, this is Chatham County, this is Savannah, is a patchwork that is pretty invisible to the driver. We drive around, we take this for granted. But what it means is there's many jurisdictions involved in managing our road network. And all of these jurisdictions have different levels of duties and obligations. So the next slide, please. And what this means is that there's different ways that an individual property owner or community member can get upset and want the government to do something about the road. And this is just a chart distilling of sometimes people want to compel action please do something about the road, county, and that's a mandamus action. They may say it's a nuisance. This is creating a nuisance to my property. It's a nuisance claim. Could be negligence, the action that the government is taking. What you did do to repair the road or what you didn't do is causing harm. It's flooding into my property. It's causing damage. That's a negligence action. And then you could also perhaps bring a claim saying, whatever you've done, I don't like what you did, or you haven't done enough. It's changed my access. It's changed my property values. That could be a constitutional claim or takings claim. Next slide. And the point of this, and certainly, you know, that we have a long law review article about all of this, but the point of this is that every jurisdiction in our study area and in the Southeast has a different level of duty or kind of duty, whether it's a state, county, or municipality. And so this is just to illustrate that how challenging it could be to figure out for an individual what might happen, or when you're planning what might happen related to the duties to maintain. And so next slide. Local governments, all governments, state and fed, have levels of sovereign immunity. What that means is there are different ways governments can protect themselves from suit. This is an old doctrine that the king can do no harm. But again, if I could show you a chart of different levels of sovereign immunity, and over time, over the past 100 years, it's really eroded. So there's lots of ways to get around sovereign immunity so that you can bring a lawsuit against a government. And one of the things we want to do, and we're continuing to do and write about, is how can local governments or state government maintain their sovereign immunity so that they will feel free to take the actions they need to do to protect the community. Otherwise, they feel vulnerable to lawsuit, if that makes sense. Next slide. Very quickly, a lot of us are adaptation folks, and so retreat is a term of art. We often hear a lot about in adaptation planning. In the road context, that's really analogous to abandonment. That's the term of art that's used to describe the government process of abandoning roads. Next slide. And again, you can look across the Southeast and realize that each level of government has a different process or a different standard for abandoning a road. And, you know, the point of this is it depends on who owns the road and where it is and what the standard might be. And for example, North Carolina, if you're a county, can't do it if there's an adjacent landowner that would be deprived of access. But then there may be a different standard, say in Georgia, a municipality might be able to do it if it's no longer serving a substantial public purpose. So you can see how important these standards could be in giving the government, local government or state government or county government leeway to do what they need to do to make good adaptation decisions. And these standards, I think, are going to need to be revisited and thought about so we can make better decisions that serve both the public interest but still protect individual property owners to the best extent that we can. Next slide. Unfortunately, for local governments, authority to abandon doesn't eliminate potential takings claims. If you click again, if you don't mind clicking again, there's some takings claims. This is how a property owner will say, this abandoned road, by taking away this road and no longer maintaining it, my property value has gone down, and that can be considered a takings. And this may be even if the property owner still has access to his or her property. It just may be the quality of access or take more time, and that still has been held to be a takings in some instances. Next slide. What are some solutions? There's a lot to think about. We're probably going to want to consider moving toward different types of duties to maintain. What could be an adaptive duty? What is the right standard to evaluate whether or not a government has actually been negligent, or whether the government has taken good science into account, has taken good planning into account, has done all the things that we think could be more resilient outcomes for the community. There are, my colleague Thomas Rupert at Florida Sea Grant has some nice work related to model ordinances where maybe we need to begin notifying property owners they live in an environmental compromised area. And if you buy property there, you can't expect necessarily the same quality of road or maintenance in the area. And he's been working on that in several places in Florida. That's common in the Midwest with ice, with snow, and very rural roads where basically the government's, has it as an environmentally type of compromised road, and people know that, so their expectations of the road are less. And that may be something we need to move to as well. Certainly that patchwork I talked about can be difficult, and more consistency would probably be very helpful as we do planning. I know it's 12:05, and so I don't want to go any further and so I will be glad to wrap it up right here.
Thank you so much, Shane. As a lawyer, I appreciated all of that very much. Perhaps I had a little bit better background in it than I did in the very pipeline piece from John. Next, we're going to turn things over to Julie Shee-Woodard from Smart Home America to give our last presentation. And we may go to the audience, we may go about 5 minutes past. We may have an opportunity for at least a question or two for the full panel. So do please remember to put any questions into the question box if you have. Thank you. And I'll turn things over to Julie.
Thank you, Michael. So for smart home, we don't really do anything with the Internet of Things or with smart technology necessarily. For us, a smart home can take the wind and the water, be it rising or coming from the sky, that structure is adequately insured, so the habitants of that structure can quickly recover after any major event, that it's energy efficient, and that in the end, after you've got all that resilience in place, then you buy the high dollar technology and you have a smart home. Next slide. So we work extremely closely with IBHS. This is a little bit of a why, and with IBHS, all of their research is focused on the losses that are seen in the United States by the insurers that write and reduce our risk and keep us wrapped in insurance. All of their research is done in an amazing facility, and our job is to get that science that is done by meteorologists and PhDs and architects and engineers out into the world and integrated into local communities. So Michael told you in the beginning he works for IBHS. He doesn't get to do the cool stuff, because he's a lawyer, but he does get to visit the lab, so he gets to see it sometimes. So we take the knowledge and the expertise out of the lab and put it into the real world to begin that resiliency process on a community level. And Lindy, this is where we can just, after this stops, we'll just click at a steady pace and I'll keep up with you. So again, bringing it to the real world, taking the science out, we are charged with educating everybody on that slide. Good, next one, that one. So our job is to touch every one of those people. And basically all of those people touch a built-it structure in some capacity. Next slide. 2017 was the beginning of what feels like the end of the world for most of us that work in resiliency. That was Harvey, Irma, and Maria, and it just has not stopped. What we know is that building codes, where enforced, key, where enforced. So you get what you inspect, work. Flat out, building codes work, but they have to be enforced, and there has to be inspection process. But the weak link in most building codes up to this point is the roof. And what we know is that once you lose that roof cover, the water pours in, and just as much damage happens when you've got that water pouring in. Next. 2/3 of the Americans in our country are underinsured, if not insured, on an average of around 17%. So if you are looking at a home that is about a $200,000 valued home, that homeowner, if you keep clicking, is missing $34,000 to recover. So that's the average American home is missing $34,000 to recover. That means when they get that check from the insurer, there's a big chunk missing. Everybody knows the stats on businesses. 1 in 4 never reopen after disaster. Those are your small businesses, the mom and pops. That's who runs the country, right? We all lived that in the pandemic when everybody had to shutter. You don't get to go to the grocery store, the corner mart. You don't get to drive and get your fresh loaf of bread. So they are underinsured. Small businesses are underinsured, but a lot of them are just not insured at all because it's an expense that they can't take on. So they have to be built correctly in the beginning, or they have to be retrofitted so they can take significant weather events and they can still open and they can still serve the populace and get the economy going again. Keep going, Wendy. This is a little video. So I am not going to go into the aspects of the fortified home standard, fortified commercial, but this is what I'm going to talk to you about today. We cannot completely eliminate the destruction that happens in big events. This is scenes from a tornado path. So we can't eliminate the damage from an EF 4 or 5 and not all of the damage from an EF 3, but we can reduce the damage that we see. EF 4s and 5s, that family needs a safe room. So what we say is we can narrow the path if we build to the fortified home or fortified commercial standard. And what I'm saying to you is that we can eliminate the debris fills that we see in EF 0 and 1s and a lot of the EF 2. Tornadoes are named for their largest and most strongest part, which is EF 5s. This is the more tornado path. That's the only time in the space of the movement of that tornado that it reached the levels of an EF 5, but it was named an EF 5. But what I'm saying is that we know how to build now, that we can eliminate the debris fields of an EF 0, 1, and low level 2 if we're building to the fortified home or fortified commercial standards. Because of the way it's constructed and because of the science behind it, we now know how to build that way and how to reduce the damages that we see. So that's lessening that time between disaster and recovery. And you are stuck in a loop, Lindy. There you go. So in the United States, where we see tornadoes and we see hurricanes, the majority of the hurricanes and tornadoes that we see are either in EF 0, 1, and 2. That's the majority that touch down, or tropical storms and CATs 1s and 2s. So that's like a 70%, and Heidi can correct me on that. So lots of low level. So what I am saying is that building to a little bit above code, I mean, it's like a smidge above code, can really, really affect the way a community looks after those events have happened. Next. So I'm just bringing your brain to that because we've talked about tornado and we're going to go into the CATs. So post-Hurricane Michael, that was a Cat 5 panhandle and coastal area of Florida. Those little squares or rectangles you see in the middle, those 5 little rectangles, you can see the devastation around them. Next slide. Those were Habitat for Humanity homes built to the Habitat Strong, which is also the fortified. So they called it Habitat Strong. They had to put their brand on it. But that's the fortified home program. So there's 3 things I need you to think about when you're looking at that house. Habitat, affordable, and can be done anywhere. Hurricane Sally was the biggest test that we have. The coast of Alabama has, I think, almost 27,000 structures. I can't keep up with how many we have, but we had 17,000 structures that made it through Sally. 95% of them had no to little claim. That means no damage enough that they had to trigger their insurance to get a claim going, okay? So think about that. 17 houses went through a hurricane, and we're gonna pause here for a second, Lenny. It was just a Cat 2, but I'm gonna tell you why it was significant. It was a Cat 2 that moved at 4 to 5 miles an hour. Hurricanes don't move that slow. And I've been on the coast my entire life. Hurricanes come in, they can be big and bad, but they move quickly through. We had 17,000 structures that were designated that sat in the eye wall for 7 to 8 hours. 7 to 8 hours. That is a beating of up to 110 mile an hour with gusts of up to 120. Not a lot of structures can take that unless they're built to take that. 95% of those structures, little to no damage. That's significant when you're thinking about recovery and what it looks like after each event. Because remember, every time a community goes through a weather event, that structure weathered. So it's taken some damage. Next slide. So what we saw was that the roof is always the key, and structures that are designated fortified have gotten to at least the minimum, which is fortified roof. If your roof is lost in a high wind event where rain is involved, rain pours into your structure, saturates everything in the attic, saturates the insulation, collapses the sheetrock, and then everything in your house is wet. And that's where you see those visuals after hurricanes where everything's at the curb. So where there's blue tarps on those two houses, you see those families were displaced. The house that has the fortified symbol there, that was a neighbor who had his house re-roofed to fortified and he had no damage. So then he was able to reach out to his neighbors and help them. Next slide. Just skip this one, Lindy. Commercial works, and it just makes sense. These are the federal partners that understand fortified. They will fund it. This is a funded CDBG project. You can keep going, Lindy. So this was the last test case we have. We've been doing this for a very, very long time, and IBHS has been doing this research for 20 plus years. That is the first affordable housing complex built with CDBG DR to the fortified commercial standard or the fortified multifamily standard. The one on the left that doesn't look too great was a half-mile away. That was also affordable housing. These are projects that were in Louisiana. We've been working with Louisiana for the last 2 years to influence how their Office of Community Development uses their federal dollars to build their multifamily units. This structure was only at 90% completion when Ida went over it. That was Cat 4. And that is what it looked like the next day. Yes, there's some damage cosmetically to the outside siding on a unit, and the HVAC units were not properly strapped yet. And so they did the damage because they blew around like cotton balls, but they're really heavy cotton balls. And so the biggest thing, you just need to look at that picture and know, because this was it for us. This was our last test case. We knew how to do single family residential. We knew how to do small business, but this was the multifamily. And this will go, I'll tell you why in a minute. Just stay here, Lenny, because we're going to go back to 2017. But this is the disaster recovery money coming into the state. After Laura and Ida, we're going to see more money come into Louisiana, and the state agencies are committed to building to this fortified standard. This was a mandatory evacuation area. So had that been occupied, those families, and that's your workforce. So you think about that. That's affordable housing, but that's your workforce. That's the people that open the grocery stores, run the gas stations, open school, teach your kids at the firehouse, at the police station. So they would have evacuated, and most importantly, they would have been able to come back and start recovering instantly. The reason this is so important is that after Harvey, Irma, and Maria, especially after Harvey, Texas at the coastal bend, which is that's their GDP for tourism, lost every single affordable housing unit, every single one of them. If you lose all of that, you do not recover and you do not reopen your community. I'm going to end right there so that we can stay on track.
Thank you so much, Julie. We don't have any questions that I can see in the question box, and it is now a few minutes past when we were due to end. So I think we're going to take a lunch break. Come back at 1 o'clock